Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is My Calendar Part 2. So the problem statement goes like this: you are implementing a program to use as your calendar, and you can add a new event in the calendar if adding it will not cause any triple booking. Okay, and the definition of the triple booking is given that a triple booking happens when three events have some non-empty intersection. Okay, so at some moment uh, is common to all of the three events. Okay, the event can be represented as a pair of integers representing the start and the end time. Okay, and it is to be noted that the end time that you will be getting will not be included into the events duration. Okay, so if you take them as intervals, so this side it will be open. Okay, so end will not be included. The range of the real numbers or the moments will be lying between the start and the end, excluding the end. Okay, so you have to implement the my calendar 2 class, in which there will be a constructor of the class. Okay, that will be initializing the calendar my calendar 2 object, and the second uh, is the function that or a method that you have to implement, and it will be taking in two parameters, start and end, representing the starting and the ending time of the event, excluding the end. Okay, and you have to return true if you can add this event to your calendar without causing any triple booking. Okay, otherwise you have to return false from this particular method, and we will not be adding that event to the calendar. Okay, so this is the problem statement. Now before thinking of an approach, let's have a quick look at the constraints. So according to the constraints, these start and end points of the event will be of order 10 raised to power 9, and at most 1000 calls will be made to this book function of your calendar. Okay, class. So these are the constraints. So let's try to think of an approach. So see, if let's say there are some events happening and they are causing a triple booking. Okay, so let's say this is S1, S2, S1 E1. So let's take the same colors, S1 E1, and the second one is S2 E2, and the third one is S3 E3. Okay, so you see, if these particular events are overlapping at a particular instance, or there are some moments which are common to all of the events. Okay, so then we will say that it is causing a triple booking. So here triple booking is happening. Okay, so what we will be doing is, firstly we will add the event to the calendar, and then we will check whether it will cause any triple booking or not. And in order to check that, we will be applying a technique, you can say. Okay, and the technique is, let's say there is a number line denoting the time units. Okay, let's say it's starting from 0 and then 1, and then corresponding to these there are some entries. Okay, and here also. Okay, let's mark these numbers, 1 2 3 4 5 6 7 8 9 and 10. Okay, so let's say these are the time units. And let's say that the event that you were trying to add was this one. Okay, event we are trying to add. Okay, and these two were already there. Okay, so these were the events already in the calendar. So events already in the calendar. So in this particular case, see, we will be using a technique called prefix sum. Okay, so I will prefix sum is in a way you can say running sum. So for example, if the numbers are given to be, let's say, A, B, C, D, then the corresponding entries of the prefix sum for this particular one, let's say this is an array. Okay, so A, then A plus B, then A plus B plus C. Okay, and for this particular one it will be A plus B plus C plus D. Okay, so in a way it's running sum. We are adding everything that we are encountering. Okay, first we encountered A, fine, we took only A, then we encountered B also. We were already having A, so we added it to the B to the A. Then we were already having this much, then we added C. Then we were already having this much, then we added D. Okay, so this is the prefix sums concept. Okay, and now you might ask that how this concept will be helping us to check whether we can add a particular event or not. Okay, so let's say uh, we have added this event. Okay, now we will be checking are there any conflicts or not, or triple booking or not. The approach will be to add the event first, and then if triple booking is occurring, then remove it and return false. Okay, saying that we cannot add the event. And if no triple booking, then you will say that we are good to go and we have added the event which will not cause triple booking, and you will return true, saying that the event is successfully added. Okay, so this is the whole approach. And to find out if it is causing triple booking or not, this whole prefix some technique will be applied. Okay, if causing triple booking or not. So the whole focus will be on this particular implementation. Okay, so let's see how this number line and prefix sum will be helping us. So let's clear the board a little bit. So see, what you will be doing here is for each of the entries of start entries of each of the events, you will be marking them with +1. Okay, so initially let's say this represents an array kind of situation, and every entry will be 0. Okay, so 0, all these will be zeros. So these are different moments, and these zeros are representing that these moments are not in any event. Okay, not in any event. Okay, now the first event came, and let's say you try to add it, then this start point will be the increasing the moment uh, count of being present in a particular event. So we will say that the presence of this moment is increased by 1. Okay, and see, if you do a running sum, the prefix sum that I was mentioning, so this +1 will be carried forward. always carried forward. Okay, so in order to nullify its effect, what we will be doing here is, uh, once you have added +1, then for the end point, okay, let's say it was occurring somewhere, let's say instead of here 5 was somewhere here. Okay, so let's say 5 was here and it's 0 initially, so you will be adding -1 here. Okay, because see, first thing is that this end is not included, it was a open interval. So when you will be doing prefix sum, then it will be looking something like this: 0 0, then 1, then obviously this 1 will be carried, and this 0 will be added, so 1, again this 0 will be added and 1 will be carried. Okay, so again 1, and then this time this 1 will be carried and -1 will be added, and it will result into 0. So see, exactly for the intervals actual range, you are marking increasing the moments occurrences in a in the number of events. Okay, so okay, or this represents number of events moment is occurring. Okay, so that's why this -1 will help us, and prefix sum will be able to tell exactly how many number of time events this particular moment is included. Okay, so we will do that for all of these. Let's do that for blue ones, adding +1 for the start and -1 for the end. Okay, and let's do for the yellow one. So for the yellow one, +1 for the start and -1 for the end. Okay, so now let's do a prefix sum. Okay, so rest of the entries will be 0 anyways, so these will be zeros. Okay, so let's do a prefix sum, and let me remove this part so that it should not confuse you. Okay, so 0 0 1, then 1 plus 1 2, then again 1 plus 1 3. Okay, now 3 minus 1 2. Okay, and again -1 is there, 1. Okay, and again 1 is there, so 1, again 0. Okay, so see, if you see this particular prefix sum array, okay, or prefix sum of the above, this is the prefix sum for the running sum, then you would be able to see that there is a moment in the whole number line or the whole scenario which is having more than 2 events associated with it. Okay, and it is resulting into a triple booking. So this is how you would be able to know whether addition of a particular event to a calendar will cause triple booking or not. Okay, so this is the whole logic. And see, since it was mentioned in the constraints that it will be of order 10 raised to power 9, the start and end points, so it would not be feasible to use an array kind of structure, because I think according to my experience, it is somewhere around 10 raised to power 5 order size is accepted on in most of the online judges, and if you go beyond that, then it will cause some trouble to you and saying that memory limit exceeded or something. Okay, so that's why we cannot take array, so array is out of the picture. So what kind of other structure we can use? So we can use a map. Okay, so map will only store the entries which are basically there in the, uh, booking, which will be passed to the booking function, and at most 1000 calls will be made. So you can say if you take start and endpoint both, so it will be around, you can say, uh, 2 into 10 raised to power 3 order of space that you will be using. Okay, so now but this map will not provide you the number line kind of structure. We would be for sure requiring that, because we want that those entries should be sorted in some particular order, or and here we were using the ascending. So version of map which we can use is tree map. Okay, I am talking in context of Java, and if you are a C++ folk, then map would be the data structure that you would be using. Okay, or some similar kind of inbuilt data structure which keeps the entries in the sorted order. Okay, so what does this particular thing does is it keeps the entries according to the so see, firstly there will be key value pairs in the map. So all the entries will be sorted according to keys. Okay, let me change color here, in ascending order. Okay, so you will be getting a number line kind of functionality. Okay, when you will be traversing the entries of the map, you will be getting the entries in the sorting order, and so the key will be the moment. Okay, and value will be the number of times this moment is occurring, number of events this moment is occurring, number of events a moment is occurring in. Okay, so this is the whole logic that we will be applying, and these are the inbuilt data structures that we will be using. Okay, so and if you are worried about that the implementation will not be there in C++, you need not to worry about that. I will also provide implementation in C++ also. So in the discussion we will be discussing the Java's implementation. Okay, so let me bring the code to the board, and let's remove this part. So this is the whole implementation, and let's see what's happening inside here. So see, as we talked about that we will be needing key value pairs, and key will be the moment, and value will be the frequency moment occurs in events. Okay, so in a way start and end are moments in themselves. Okay, because you will be able to see that number line example that we were taking. I think I removed that part. Anyways, you should be pretty much clear about that. See these number lines that we were taking. Okay, so this particular number line was representing those moments, and here the key will be representing that, and all the moments will be in sorting order, so we will get a number line kind of structure. Okay, so that is the whole uh, logic behind using this tree map. Okay, now you will be initializing it in the constructor. Okay, so it's a implementation thing only, then the whole logic is this much. Okay, firstly you will be trying to add the moment to the calendar. Okay, or not the moment, add the event, add the event in the calendar. And how you will be doing so? For start you will be adding +1, because if a moment is starting somewhere here, so +1 for start and -1 for end, because uh, you would be wanting something like this, and here it should be nullified because end is not included anyways. So that's why in order to nullify the whole effect in the prefix sum, we are taking -1. Okay, then adding -1 for the end. Okay, or subtracting 1, basically the moment frequency might not be 0. Okay, so once you have done that, then you will check whether addition of the current event caused any triple booking or not. If not, then you are good to go, and if yes, then you will return false, saying that you cannot add that event. And let's see how this cause triple booking function is being implemented. So essentially we are seeing this is a prefix sum basically. Okay, so you are checking here, the doing here the same thing. Okay, so you are getting the frequencies and just adding them. Okay, so once you have added all the frequencies, and while doing the addition, there, let's say there come a certain point when this particular frequency increases more than 2. Okay, at that particular point you will stop your prefix sum, and you will say that this particular thing will cause, you know uh, triple booking, and so we cannot add this event. In that particular case, you will be removing that event. Okay, so this is the removal of the event. Okay, removal of event. So how we are doing the removal? We are doing just reverse of what we did here. Okay, here we added +1, and here it was -1. Now things will be reversed. Here it will be -1, and here it will be +1. Okay, removing the effect of that event. So next time you run the prefix sum, that event will not be there. Okay, so if that is not happening, that no moment is sharing more than uh, 2 events, so then, or no events are sharing more, no two event more than 2 events are sharing a moment, so in that case you will be returning false, saying that it is not causing any triple booking, and we have added the event which will not cause any triple booking, and we will be simply returning true. So this is the whole logic. And if you are new to this concept of prefix sum, I will be adding link of an article describing what it is. And if you want, just in case you want to have a in-depth understanding or want to read more about it and its possible use cases, so you should definitely check the link in the description box. Other than that, if you want to have a discussion on time complexity also, see, let's say there were n bookings. Okay, so time complexity wise, since you are doing a linear traversal here of the entries in the map, and there can be n entries in worst case, so it will be order of n square. Okay, and if we talk about the space complexity, so see, map can be storing somewhere around order of n entries, because basically start and end of both of the each of the bookings that we are trying to make. Okay, so these will be the complexities, and this is the approach. If you are still having any kind of doubts or any queries in general, then you can ask them in the comment section, and I really hope this solution walkthrough added some value to your journey of honing your DSA skills. Keep solving more and more problems, and I'll be seeing you in the next video. Thank you for watching.